Hey everyone, it's Jana from Open Minds LLC, and I'm here to solve linear equations in one variable. Okay, so whenever we're solving linear equations, our goal is to find the value of the variable, and we do that by isolating that variable using inverse operations to move the terms that are on the same side of the variable to the opposite side of the equation. And whatever we do to one side, we do it to the other to keep our equation balanced. It's like a scale. So for the first problem, we have x plus 5 equals 12. So we are going to subtract 5 from both sides of the equation. It cancels on the left. So x is equal to, so 12 minus 5 is 7. Now I will always recommend that you check your answers. So I'm going to come down here below and I'm going to substitute 7 in place of x in the equation. And 7 plus 5 does equal 12, so that checks out. So our answer of 7 is correct. All right, moving on to the next one. 3x minus 11 equals 16. So this one we have a two-step transformation. So the first thing I would always recommend is start from the outside and work your way into the variable. So you would move the 11 before you move the 3. Okay, so you want to go ahead and add 11 to both sides. All right, so it cancels on the left. So 3x is equal to 27. All right. From here, we will then divide both sides by 3. Okay, so just to point this out, when you see this, a variable and a coefficient, the number in front, this implies multiplication. Okay, that's a single term, 3x, but multiplication is being done. So in order for us to move the 3, we have to divide it. Okay, this is a common area that I find that students sometimes struggle with. So we're going to divide both sides by the 3. So now x is going to equal to 27 divided by 3, which is 9. And again, we are going to check. Okay, so I'm going to come down here to check, plugging in 9 for x in the equation. So 3 times 9, all right, minus 11. Here we have order of operations, okay, PEMDAS. So in this case here, multiplication comes before subtraction. You will multiply 3 by 9 to give us 27. Then we will subtract 11 from that. So that will give us 16, which checks out. So our answer of 9 is correct. Next problem. 2y equals 24. So remember how last problem I told you whenever you have this single term, your variable and a coefficient, that is multiplication. So the inverse operation is to divide both sides of the equation by 2. So y is equal to 24 divided by 2 is 12. And again, we are going to check, okay, by plugging 12 in place of y in the equation. So 2 times 12 is 24. So y is indeed 12. All right, moving on. 4 times y plus 2 equals 20. Okay, so for this one, remember, so here the 4 is outside the parenthesis. So we want to deal with that first. And here, this implies multiplication. We're multiplying 4 times what's in parentheses. So we want to do the inverse, which is to divide both sides of the equation by 4. Okay, so it cancels here. Bring down the y plus 2, which equals to 5. All right, then we are going to subtract 2 from both sides. So y is equal to 3. And we are going to check. So plug in 3 for y, and we're going to simplify. Again, PEMDAS, parentheses, is first. So we're going to add 3 and 2 to give us 5, and we'll multiply that by 4 to give us 20. So this is correct. Y is equal to 3. All right, our last set of problems here. So we have lovely fractions. All right, so we have 1/4 x equals 11. And I'm going to rewrite this. All right, and so we see here we have a fraction in front of our variable. And again, remember, we're multiplying, but we have to divide by the 1/4. And whenever you are dividing by fractions, I always love to share with my students that R word. We have to multiply by the reciprocal. Okay, so in this case, if we are dividing by 1/4, we are actually going to be multiplying by its reciprocal, and we just simply flip that fraction. So the reciprocal of 1/4 or 1/4 is 4/1. We're going to multiply both sides by that reciprocal. So 4/1. All right, that's how it cancels from the left side. Okay, so you have to think about it from that sense. I'm always trying to get it to cancel in order for me to isolate that variable. Okay, so it cancels on the left. So x is equal to, so I have 11 times 4/1. And remember, our whole numbers are actually, they can be expressed as rational numbers. They simply just write them over 1, if that helps you. All right, and multiply this. So 11/1 times 4/1. And we're just cross multiplying there. So 11 times 4 is 44. Okay, 44/1, which is equal to 44. Okay, so again, we want to check. Okay, so from here, I'm going to plug in 44 for x to see if I indeed get 11. All right, so again, if it helps you, you can rewrite that as saying 1/4 times 44/1. Okay, and I'm going to show you 2 ways to simplify this. One way is just to multiply across, so you'll have the 44/4, okay, and 44/4, that simplifies to 11, okay? Or you can do it like this. Another way is, again, so if we have this 1/4 times 44/1. So I like to do the diagonal cancellation. So meaning like just to check to see, can I simplify these fractions? So I know that 4 goes into 44 11 times. So this is useful, especially if you have a value that's higher than 1 in your numerator denominator. But when you're canceling out, so I can also do it like this as well. Okay, so I'll get 11 is equal to 11. All right, so that checks out, and our answer of 44 is correct. All right, our last problem is a -12 equals x/7. Okay, so for this one, always focus on where your variable is and what's near it. So we're dividing by 7. So, of course, the inverse operation is to multiply by the 7. All right, so it cancels on the right. On the left, so 7 times a -12 is a -84. Remember your multiplication rules with the signs. If they have opposite signs, your product will be negative. If they have the same sign, whether they're both positive or they're both negative, then your product will be a positive. Okay, so make sure you remember your sign rules, and that also applies to division as well. Okay, so we'll get x equals a -84, or if you're comfortable with reading it with your variable on the left side, this is also fine. So then we're going to do the last thing. We're going to check to make sure that this is indeed a -84. So I'm going to plug that in place of x. And so when I divide 7 into -84, it indeed gives me a -12. So if you remember your multiples of 12. All right, so this checks out. So x equals a -84. All right, so that is solving linear equations in one variable. If you have any questions, feel free to leave a comment I will definitely look forward to being able to assist you in making sure that you have a better understanding. And tune in to my next video where we'll be exploring word problems with one variable linear equations. All right, so thanks for tuning in, and I look forward to chatting with you all soon. Take care. Bye.